Testing. I think we are live streaming on all platforms. Jay Dubensky for Weather Co-op, and we are live tracking severe weather ongoing across the Dakotas this evening. We have two tornado warnings that have been ongoing now for several counties as these two very strong supercells are moving from west to east, almost on a due east direction. So if you are in the path of these storms, it is the characteristics of the behavior is a little bit more directly east in their direction rather than northeast, as we most often see with these very large supercells. The cell in South Dakota, so north central South Dakota, is where we want to focus first, because that cell appears to be just gaining strength by the minute practically here, and is now looking extremely healthy, well ventilated, classic Flying Eagle signature there, where if you want to visualize this, I'll point it out to you. It looks like a flying eagle in its presentation, with the head being here. This is the hook echo. This is the back area of the storm where you're going to find rotation, if there is any, in a mature supercell like this, and a tornado if it exists. And with the tornado warning, we do have a confirmation that a tornado was occurring, and if we bring that up right now, we'll see what the latest update is on that. So this is a PDS statement, meaning particularly dangerous situation statement now. So upgraded by Storm Prediction Center. It confirmed large and extremely dangerous tornado was located near Mound City. And if you were on the last live, you know we were looking at Mound City as an area in the path of this storm. Now 11 miles south of Herod. And if you live there, forgive me for the pronunciation if I'm off the spelling, Herreid, moving east at 20 miles per hour. So this storm is cruising. And this tornado now, we are 6, 7, we are past dusk here in this area, so we're dealing with a nocturnal storm. You won't be able to see it as well as you would during the day, but if you are anywhere in this path, so we are looking at southeastern Campbell County, please seek shelter immediately. If you have a tornado shelter, get there now. If you do not, get into your basement. If you do not have a basement in the building you are in, please go to the centermost room in your house, in your building, in your business, wherever you may be. Get as many walls as you can between you and the outside. This storm looks very, very dangerous right now, and I'm going to go in here a little bit deeper in the radar. We will bring in, let's see, we have, I want to get to more of a velocity product here so I can show you what the wind speeds look like right now. And we'll get that warning off. Oh yeah, here we go, gate to gate shear. Okay. It's hard to pinpoint this exactly with the pointer because, you know, we're trying to hit something in motion here. But what's important to note, and I'll go through this very specifically for you, when we're dealing with a rotating storm and we have this type of structure that you're seeing right now, the brighter the coloration between the red and the green here, the more intense the winds are, the higher the wind speeds are. And we develop that into what we call a gate-to-gate statement, which means the speed in miles per hour moving toward and away from the given radar site. And right now we're showing what is one of the most impressive couplet signatures that we have seen this year. And I'm making a very bold statement here. This entire season, I don't recall too many storms showing this type of signature especially this time of the day. Uh, Typically, you'll see these storms in the plains in the late afternoon. We're getting really late in the day now, and this storm just seems to be gaining strength, not losing strength as we go along. Even with the last scan there, if you can see that, and I'm going to stop this scan where you have, bring that back on. We have the brightest coloration and the most defined image of this storm at the point of the last scan. So here in the reflectivity, you can't see it the same way as we do in the velocity. This is more of the precipitation shield view of it. But what this does show us is how large this storm has become, this single supercell. So, and I go back, and we'll take this back into the velocity. This will show that wind speed, and we have vertically integrated liquid. We have a lot of different products going on here right now that we're going to highlight. Our storm mean velocity product also, which is showing us, let me get over here. I'm going to give you as many of these products as we can right now so that you can see this in totality. Okay, so this is our vertically integrated liquid, and we're showing you wind motion here with this storm. And one of the advantages of this particular system we have here at Weather Co-op is that we can show you in the vertical what the wind motion looks like. And these wind barbs here, as you can see, as the storm matures, you're getting vertical motion to develop within the storm structure. So there's a lot of lift. We do have a lot of convective energy here. Cape values were spiking over 4,000 joules per kilogram in this general area over the last few hours. And we had approximate 45 to 50 knot shear in this area, which gives storms all of the rotation they need in the vertical column to start rotating. Even with the elements in here, we'll give you the watches and warnings. This is the tornado watch in the yellow, and in the red here we have the tornado warning again, and I'll zoom in on that, and it looks like we've dropped the tornado warning. So the tornado warning has expired in North Dakota. And that cell does appear to be losing some of that structure from what it was just 15 or 20 minutes ago. But this storm here in northern South Dakota just continues to look very impressive, very healthy, and it's going to continue to produce damage.
It's an HP.
Yeah.
So it's an HP.
It is an HP supercell. It is producing a lot of rain in addition to the wind here, and up to 2-inch hail with the warning that was issued. And I wouldn't be surprised to see 2-inch hail with this. And I'm going to go off. Let's see what we have for hail here. Yeah, so this is our hail product, and with that purple coloration, that's where you could potentially be seeing, and right near Mound City again, you could be looking at 2-inch hail to go along with the tornado that we have confirmed reports now is in your area. We are going to reload some of our products here. We'll be back on shortly. Please stay tuned to Weather Co-op for all the latest information on this developing severe situation. Bringing everything back. All right, we're coming back to you live. Just make sure we're live on all of our platforms. Yes, everything is up and running. So if you're joining us on YouTube, IG, Facebook, X, Twitch, wherever you happen to be, we are covering this very, very dangerous situation right now, ongoing in northern South Dakota with this tornadic supercell thunderstorm that has a PDS warning attached to it. The particularly dangerous situation. And we've been tracking this storm now for at least 90 minutes. Very long track supercell as well. And we're going to do a little bit more of an in-depth dive here. We have a few different options that I would like to show to you. So for anyone who's joining in, please comment if number one, if you happen to be in South Dakota right now, or even North Dakota with the storms moving across central North Dakota. These storms are very dangerous, so please seek shelter immediately. If you are out at a game, you're outside with the kids for Little League or soccer or whatever, and school's back in session this week, a lot of outdoor activities going on in the early evening. These storms are not to be messed around with. If you are in north central South Dakota, follow that, the storm that's heading toward you is very violent, very dangerous, and was producing a confirmed report of a very large wedge tornado with it. So find your shelter. If you do not have a shelter, please go into your basement. If you don't have a basement, go into the most interior room in your structure and put as many walls as you can between you and the outside. So in looking at the setup here, we're going to take a look at the satellite view because it shows what's going on probably the best for everybody to understand. This is the loop of the high-res NOAA satellite image over the last several hours. And what you're seeing here is a very strong low-pressure system that is straddling the northern U.S., southern Canadian border. And with it, over Montana, you're seeing the cold front extend out ahead of that low pressure system, and it really does have a kind of a mesmerizing appearance to it on the loop there. It's a very long trough that's associated with this, and a lot of cold air pouring in behind it, and that cold air is helping to trigger these storms. We have warm air rising out in front in the warm sector. We have a lot of cold air pushing in behind it, so we're getting a lot of lift, we're getting a lot of motion in the atmosphere, and right over the Dakotas you can see in those last several frames the very rapid, very intense convection that has occurred. We think this is going to be ongoing for the next several hours here, and the storm over Montana is bringing snow with it. Yes, I said snow across Montana. Freezing temperatures. There are frost and freeze warnings for many counties in Montana, but the severe threat is what matters the most right now. And looking at this structure, looking at the ventilation of these supercell thunderstorms, it's something that they need in order to maintain their maturity. They're not having a problem right now. The atmosphere is definitely supporting the severe storms, and with the indices that we look at in meteorology to measure the level of, let's say, fuel, we call it energy, potential energy, but it's fuel for these storms to grow and maintain their strength, is very abundant right now. We have a lot of warm air. We have a lot of humidity. We have a lot of vertical motion. We have a lot of wind shear. The only thing that's working in the negative here is what we call our SIN value. It's convective inhibition. And it's keeping more of these cells from going more severe, quite honestly. This could be an even worse situation right now. But the storm in South Dakota is bad enough, and we're going to get right back into that right now. And I'm going to zoom in here and show this to you and give you an update. You can see, look at the swirl with the low pressure system, and then boom, this convection just exploding across North and South Dakota. Here's your storm that is of most concern. Right now we have, and we can bring this right up to the minute for you. We'll get the latest warning that's associated with this. Let me get that box. We have a lot of precipitation going on here, so we have to just get that out of the way for a second so that we can actually see the warning itself. It's there. There we go. Okay. You can see the robust nature of these cells, even working into North Dakota. Quite honestly, they did not extend the tornado warning that was with this cell that moved from near Steele. Actually, it was Bismarck, moved near Steele, and now heading toward Jamestown. But I'll show you in a second. There is still rotation associated with this aloft. So at the cloud level, there's still a lot of energy in motion here. So it's not out of the realm of possibility that we won't see more tornadoes here, and that's why we still have in the yellow here, you see this tornado watch box, which covers a large section of both North and South Dakota. I am going to get into more of the sweeping radar here and show you a closer view of this one cell in South Dakota. And I have to say, there are graphical images when you're looking at Doppler radar that really do impress you. And this is not the way you want to be impressed, but the images that are coming from this storm are, I mean, it's just kind of an awestruck feeling when you see a storm this strong, this powerful, especially this time of the day. And now we're even into evening. We're not even in the day. We're going into night here. It's not in any way anything that you want to be playing with. The storm means business. It is only continuing to march toward the east, not even really a north-northeast track, which many of these storms would take. This is more of an east, almost due east, maybe a little bit of a northeast component there at the end, east-northeast direction, heading toward Eureka. And I'm going to take a slice of this to see what it looks like in the atmosphere in a second, but you can clearly see there in those last few frames, and I'll try to back this out just a little bit more, where we have a very strong couplet of signature here in this hook echo, and even in the reflectivity scan, you can still see that image. Okay, now I'm going to take a little bit of a 3D slice here in the atmosphere and show you what the storm itself looks like in the vertical. And what you're seeing is a very impressive cloud height with this storm. Often when you see very mature supercells in the plains, they will get up to 50 to 60,000 feet in terms of the cloud heights. And we're definitely seeing that right now with this cell. And I'm going to go even deeper here and show you another image that we can bring in. And this is to show you more of the precip in the isosurface layers. And as this storm marches from west to east, you can see the vertical element of the precip. So we have vertical motion within the storm. So the air is rising out in front of the storm and into the storm itself. It's how it gains and maintains strength. So the vertical motion of the precipitation within the storm is something that can be measured with Doppler. And when you get enough of that vertical motion with precip, you can create the conditions for hail. you get enough collision in those rain droplets and those supercooled drops, and then they begin to coalesce into hail. And we definitely are seeing enough of a signature here in this 3D reflectivity to indicate that you're probably experiencing hail along with a tornado in this area, just to add more to it. This going back into velocity. There, that's a pretty clean image now in the slice where you can see the red and the green. And what's great about our product here at Weather Co-op is that we can adapt on the fly in real time to show you parameters that would make it easier for you to understand what it is that we're talking about. And this is one of those instances where I can change the coloration here on this velocity beam from the radar site, and you can see in a lot clearer detail the bright banding in this couplet of moving air going toward and away from the radar site, and this is a very strong indicator of a tornado. And the brighter these colors get, the higher the wind speeds are. We're getting gate to gate wind speeds here that were in that 50, 60, 70 mile an hour range earlier. Oh, here's a gate to gate shear velocity negative 34 to 31. So 34, we are easily getting into 70 mile an hour, 80 mile an hour potential wind speed. Okay, there we are. Here's our latest tornado warning. Just popped up. Tornado warning remains in effect for east central Campbell County and west central McPherson counties. The storm is located 9 miles south of Artas, or 10 miles west of Eureka, moving east. Now, and again, moving east. Remember that, at 15 miles per hour. And the reason I say that for people that don't live in the plains, if you live in the plains, you know that most of the storms that you have to deal with are moving in a northeast direction. So as as your relatives tell you stories about storms, and as you experience storms yourself, in your mind, you're thinking that the storms are moving to the northeast. So you start to plan ahead where that storm's going to be. This storm is moving more on a due east trajectory. So in South Dakota, this storm's not going to cross over the border as a typical northeast mover might by the time it gets up into the northeast corner of South Dakota. You're still going to be dealing with this storm over the next 30 to 60 minutes. So we have east movement at approximately 15 miles per hour. We have, I'm looking at all the specs here. So the thunderstorm, of course, it is over farmland, and they're referencing that in the latest warning report, that it is a very rural area. And the geography there, the farm fields, for those who are not familiar with it, are set up in grids. So it's a square grid type of farmland layout there, where you have mostly dirt roads, honestly, and then small towns interspersed between those farm communities. And if you're anywhere to the east of this storm, we're looking at Artis, and then I'll pull the box away here. So Eureka, you're looking at this storm, and we're starting to see, with time now, we're starting to see that velocity signature weaken, which is a good thing. And at least in our product here, we are still seeing the warning, but it appears that this storm is getting a little bit weaker for the first time in its lifespan, and I'm hoping that this trend continues so that we don't have to worry about this storm moving forward. But it's going to be a process. It's going to take a little while. In this loop, and I'm going back to this loop because it really does give you an idea of how a supercell storm functions. And you can see the hook echo develop on the back. This is when the tornado was first forming with this storm. And out in front, we'll say front of the storm, so to the east, you can see that notch that kind of develops in the reflectivity. And that's the inflow area of the storm where it's pulling the warm, moist air into it from its base. And then it's just rising nearly straight up in the column. And when it spreads out like that, and you see that image, that's what we refer to as that flying eagle mentioned before, you know that this storm is at its most mature stage. It's a very dangerous storm. And on the back end of that, where it's beginning to rotate and it's tipping, and you can see it here clearly in this image, how the storm tips from right to left with time, and the precip extends outward more toward the eastern end of it. Underneath the very bottom of it is where you would potentially see the tornado if it forms. So even this is a massive storm, and I'm estimating here, it's a rough estimate, but it appears that it's probably 50 miles wide. I would guess that would definitely be a mothership type of supercell if you could see it in the daytime. But the tornado really is a very small portion of the back of a supercell thunderstorm like this. So it appears almost like off balance if you were to see it visually. But what we know from the radar is that underneath this area, we are seeing that rotation, and we did have the report of the tornado. So in this last velocity scan, even here, yeah, you can see this pretty well. So I'm just going to I'll go 30 minutes and just show you the last 30 minutes here on the scan. So in the area, now it appears to be even changing its direction a little bit and heading a little bit more toward the northeast. So we're going from due east to a little bit more of an east-northeast component, which unfortunately puts Eureka right in this storm's path. We had it on the ground here in Mound City with the confirmation earlier. Now it looks like the small town of Eureka, and again, these are very small farming communities mostly, but you're going to have to be prepared for this storm like within minutes. So if you're not in your shelter already, please get there now. Now, you shouldn't be listening to me. You should be in your shelter protecting your life. All right, we'll back out a little bit into the storms in North Dakota, and it's great that we can pull this up on Velocity. Also, I mentioned this earlier, we still may see another tornado out of this cell here in North Dakota. I wouldn't be shocked. So near Jamestown, we're showing a fairly strong couplet signature there also, but this is a loft. And the radar sites that we're pulling from here are now a pretty good distance away from where this particular storm is. So there's a bit of a issue with the beam here in terms of accuracy, and you can see a little bit of beam degradation in the image. This is classic red. We'll pull up, make it a little bit easier to see it here in the brighter coloration. So this area, between Moon Lake and Jamestown, it's suspect at the moment. You may actually end up with something here, so we'll keep an eye on that. If it can stay at cloud level, that's ideal. We don't need to have a tornado, another nocturnal tornado here affecting a community like Jamestown. And then even a little bit more toward the north here, we have some storms that are raining themselves out, not of the severe variety, but certainly, if you're out there in those areas, you're going to be getting wet. And out toward the west, very briefly, we'll look at this too. Uh, these blue boxes are frost and freeze warnings, which is even hard to think about, being that we are still in the month of August. But yes, you are going to be dealing with frost and freeze and very cold temperatures across Montana tonight and tomorrow, and some of that cold air will spill into the Dakotas tomorrow. But getting back here into the most important story for the evening, this severe Warren storm. And let me grab another image here to give you a closer look at this, just because it deserves it. And we'll get these contours out of the way. Get some storm tracks in here and some storm reports. So this is a history of the storms and what they have done thus far, and you can see that we have numerous reports of hail. We do have the tornado reports. Again, in that area from, was that Moore City? Let's see, yeah, Mound City. And if you follow actually, if I go back, we'll show you how accurate this product is. See if we can get it to loop. Okay, so you can see how the velocity signature directly overlays with those warning graphics. So those are reports that have been submitted either by storm spotters like myself or other trained observers, police department, EMS, fire, and those are then recorded by the National Weather Service offices. So if I'll try to back this up a little, we'll go 2 hours, and there you go. You can see the history of the reports and the velocity signature at the same time, and we'll go back and layer up the reflectivity. Whew, look at that. So hold on, let me slow this down just a tad. So in terms of the speed here, slow it down a little bit. I don't know if you can see the difference there, but look at that hook echo as it passed over Mound City and then through the farming communities here. As I mentioned earlier, you can see the grid layout here of the farmland. Very, very classic representation of a tornadic supercell and a hook echo. Go back one more time, show you the velocity on that again, and how it overlays with the reports. And one more product, actually a couple different products here. So here, this is this what we call a correlation coefficient product, and it's a way that we can measure. Get it back. I promise I'll get it back. So one of the things that we can do with the CC is see particles in the atmosphere that don't have a natural characteristic. So let's say a hailstone would have a different appearance than a raindrop. A piece of wood would have a different appearance than a hailstone. Debris signatures would look different than precipitation signatures. And the CC product allows us to see that in really good detail. And if I remove, okay, I'm going to remove this and pull up the CC. And I'll take the cloud contour off. Okay, watch this. Okay. So in this scan, it doesn't look, if you were not trained in how to look at this with Doppler, you wouldn't see all that much, right? Okay, just some red and some yellow, what's going on here? But this is showing you that here in this back edge where I indicated earlier, where you would likely see a tornado in a supercell, you have more of a debris signature right in this area. If you can see that, I'll get the pointer on. Okay, see that right there? You can follow that. That's indicating that something on the ground, and we always say it's debris, but something on the ground has been sucked up in a tornado and lifted aloft. And hopefully in this case, it's just earth, potentially crop. You don't want to see crop damage, but as long as it's something like that and not, homes, vehicles, things that can get tossed aloft in a tornado. But that's a way that we can see some of the difference in what's being thrown aloft. This is spectrum width, and it's not, we don't use it all that often, but in tornadic events, it's a helpful tool in being able to see the potential, the indicator that we may indeed have a tornado. And you can see in the images here in the loop, it does appear that we have a pretty strong spectrum width difference there in the center. So all that's saying, really, at the end of the day, is that we're confirming with everything that we can see in our products and access to the closest Doppler radar sites that we're not shocked that there was a report of a very large tornado in this area between Mound City and Eureka. Even now, right now at the moment, and we'll stop this radar right here, right now, we can see that we still have a little bit of a difference here. Thankfully, it's weakening. We'll get into just 15 minutes and show you the difference there in the 15 minutes. So as it's approaching Eureka, the system does look to be at least less threatening. That would be my call on it, less threatening than it was 30 minutes ago. And then the storm here impacting Jamestown. Straight line, we're probably having some wind damage here, getting into the 30 to 40 mile an hour range, at least from what we can see aloft. The beam in this general area is not really getting down as low because of the radar site being up here. This is the Mayville radar, so it's right at the extreme edge of the most effective part of that radar beam, and it's just out of range from the Aberdeen radar, which is the next closest radar to that storm, and then Bismarck is way out here. So this is an issue, and it's one of the reasons why live storm reports are so important, and having those confirmation reports is so important to us at Weather Co-op, and to National Weather Service, and to local EMS, because storms like this that are somewhat caught in between the radar sites can be producing a tornado potentially, and we can't necessarily see that in a confirmed way with the radar tools. So it's still important to have people who can give the visual confirmation in the areas that are impacted here. And that's why the tornado watch covers such a wide area. And I can get the watch back up here. So you can see that this storm is still within the tornado watch box. Even the storm in South Dakota is still well within the tornado watch box that extends down, even down toward Pierre, South Dakota. So we're not out of the woods here. We're still going to see some activity overnight tonight, and eventually that'll push over toward the eastern border. Fargo's probably in line for some storms, and then getting out into Minnesota, you'll probably see this impact you if I get back into the reflectivity. There you go. So you can see how these storms are training mostly toward the east, and even a couple of cells out here in front. A little bit of a boundary there, kicking up some action too. But this is the main player. This storm that's impacting Eureka. Let's see if we can get some. I want to get wind on this to see what's going on here. So, a couple of things to note. You can easily see the air motion. So this is your boundary area where you have your front. So you have the air motion behind the front coming down from the north. You have the air motion out ahead of the front coming up from the south-southwest, south-southeast. Sorry about that. And that's where you will introduce the maximum amount of lift in the atmosphere. And the storms will feed off of that. That's one of the ingredients that they need. And that shear within the line is one of those important ingredients that we consider in the values, and that was in the 45 to 50 knot range of shear not too long ago. But thankfully, the severe indices are going to drop off quite rapidly once we get toward midnight here and into the very early morning hours. So the storms will lose some of that energy that they need to maintain severe levels. But as you can see, we're going to be dealing with at least some weather for those of you who live in eastern North and South Dakota, and then far western Minnesota going into the next several hours. So that's it for now. Please, if you're in this area, keep an eye on the situation. And if you're off to the west there and you're in Montana, bundle up. I guess you want to test the furnace and the stove, because it is going to be a very cold night tonight. And if you're in agriculture and you're farming in Montana, you're used to the season coming to an end close to this time of the year, but even it's still a little bit on the early side to see a killing frost. But some of those areas in western Montana are going to see some snow and are going to see their first killing frost of the year. That's a little surprising in the weather department to have that going on and still in the month of August. But it is going to be the case here. We're dealing with snow, and a lot of the mountain areas in the Rockies are going to see very cold temperatures with this system moving through over the next day or two. And some of that cold air will get into Wyoming also, and eventually into northern Colorado. So get ready. You're going to see it. I mean, we're not quite to foliage season yet, but it's not too far off now. Early September, mid-September, we start to see a lot of those higher elevation areas and the northern areas begin to go into fall mode. All right, have a great night. Stay safe and stay connected to Weather Co-op.